So in this video, we're going to look at what are called colligative properties. Now, colligative properties are properties of a solution that depend on the number of particles that are in the solution. Okay, so when we're looking at things that fall into this category that are considered colligative properties, there's going to be some sort of concentration involved with the property, because that is looking at how many particles of solute are in the solution. So there's two colligative properties that we're going to look at in this class. The first is freezing point depression. Freezing point depression is when there's a solute that lowers the freezing point. Okay, so let's use water as our example. So water's freezing point is, pure water is 0 degrees Celsius. When you add a solute to that, that means the freezing point is lower than 0 degrees. So it has to be colder in order for the water to freeze. Boiling point elevation is the opposite, raises the boiling point. So the boiling point is the temperature when a liquid turns into a gas. Okay, so boiling point elevation happens when you add a solute and it raises the boiling point, so it means that it has to be hotter, it has to be at a higher temperature in order for the liquid to turn from a liquid into a gas. So there are ways that we can calculate that change in temperature. And the equation is the same for both boiling point elevation and freezing point depression. I left a G off here. Let's add that back in. Okay, so the change in temperature is equal to some sort of constant multiplied by the molality. So let's talk about each of those. So you'll see delta TB or delta TF, F for freezing, B for boiling. Okay, so that's the difference of the temperature compared to that solvent's typical freezing point or boiling point. So that's how much higher or lower it is compared to when it would normally freeze or boil. So it's not the temperature at which it now happens, it's how much that temperature is different from what it is when there is no solute. We have KB and KF, just like B is for boiling and F is for freezing, just like with temperature. Those are constants, so those are numbers I'm going to have to tell you. So I'll tell you that here's a list of KBs for different solvents, here's a list of KFs for different solvents. And then M is molality. Okay, molality is different from molarity. So molarity is moles divided by liters. Molality, symbolized as little m, so this time it looks like meters. Oftentimes if you see it typed or printed, it'll be italicized, so it'll be slanty instead of straight up and down. It makes it look a little bit different than meters as our unit. And molality is calculated as moles of solute divided by kilograms of solvent. So they're different units than molarity. So typically you'd have grams of solute, so you'd have to convert that to moles, so divide by the molar mass. And we'd have either mass or volume of our solvent, and you'd have to use a variety of conversions so that you have kilograms of solvent. So it's going to be moles per kilogram, solute per solvent. So the units are a little bit different for that. This, when we calculate freezing point depression and boiling point elevation, is pretty much the only time we're going to use molality. Pretty much all the other times we're going to use molarity, but it's important because these are the units that our constants are going to be using. So we want to make sure that we use molality times the constant, which will get us our change in temperature.